Good morning, everyone. My name is Nikita Sharma, and I am the tutor for today. Today, we are going to study a very important topic of physics, that is the constraint motion. Okay, so let me share my screen. I hope my screen is visible to everyone. Great. Now, before starting our topic for today, first we will study the basic. So, we will start with if we talk about physics, then we divide the entire physics in two parts. Number one is kinematics, and number two is dynamics. If we talk about kinematics, then kinematics is the part of physics, or we can say the section of physics in which we do not follow the Newton's law of motion. That means we are solving our problems, our numerical problems, without using the Newton's law of motion. For example, we talk about problems of center of mass, circular motion, projectile motion, and our topic for today, that is constraint motion. If we are solving the numerical problems on these topics, then we will not be using the Newton's law of motion, and that is the reason we put them under the kinematic section of it. Now, dynamics, that means we are following the Newton's law of motion in this part. We follow the Newton's law of motion. The Newton's law of motion, three Newton's law of motion we already know. Number one is inertia. Number two is relation between force momentum. Result of that is F is equals to ma. And number three is action reaction. Okay. If we are calculating the inertia, if we are finding the relation between the force and momentum, if we are solving the problem based on the action reaction, then we will have to use the Newton's law of motion, and that is the reason we put these problems under the dynamics part of physics. Okay, this is the basic. Now we will start with our topic, that is the constraint motion. Today we are going to study about the constraint motion. In the constraint motion particularly, we will take few problems based on pulley. So we will solve some pulley problems today. Okay. Okay. Question number one is, I'm drawing the diagram here first. This is the constraint given to us. And pulley number one is here. Pulley number two is here. It's connected this way. diagram may not look that good, but our main motive is to understand the topic and how to solve it. This is wedge number A hanging on this pulley and wedge number B hanging on this pulley. Okay, the length of the string are given L2, L1, L2, L3 in this curved path. Can you see? The part of a string which is on the pulley is the curved part of a string, and we call it as C1 and C2. So L1, L2, L3 are the length of the string, and the part of a string which are attached on the pulley are the C1 and C2. So C1, C2 are the curved part of that string. Okay, this is the question given to us. What else is given to us is that block A is moving with velocity UA downwards, and block B is moving with velocity VB upward. We need to find the relation between the UA and V. Establish the relation between the UA and VB. Simple. So, in order to solve these type of question, we simply follow three simple steps. We solve these question into the three simple steps. Our step number one is, if we look closely at the question, then we can figure out that the total length of a string is always constant. Doesn't matter that if the blocks are moving or not moving or in which direction moving. The length entire string will always be constant. So the total length of a string is constant. Our step number one. Step number two, we will differentiate this length dl by dt. And what is the differentiation of the length or the distance is simply velocity, right? In the step number three, we will use the velocity separation method. We will use the velocity separation method in order to solve the step number two. The equation we will get using the step number two, we will solve it using the velocity separation method, and that is how we will be able to establish the relation between the UA and VB. I hope up to this part, the things are clear to you. Okay. So in order to solve the pulley problems of a constraint motion, we simply solve the question into the three simple steps. Step number one is the total length of a system, the string. The total length of the entire string will be constant. In the step number two, we will differentiate that length and it will give us velocity. And as we have a velocity, we will use the velocity separation method to establish the relation between the given velocities. So we will follow these steps for this particular question here. So our step number one says that the total length of a system is constant, that is L1 plus L2 plus L3 plus C1 plus C2. Why are we taking C1, C2? Because that is also part of a string around the curve length. In the step number two, we will differentiate this length with respect to time. dl1 by dt plus dl2 by dt plus dl3 by dt plus dc1 by dt plus dc2 by dt. What is the step number three? We will use the velocity separation method for the each length. I already know that total length of a string is constant. And the differentiation of a constant is 0. So dl by dt will be 0. Why? Because we know that d by dt of any constant is 0. Total length of a string is constant. That means the differentiation of dl by dt will be 0. Now dl1 by dt1. We will use the velocity separation method for this. dl1 by dt1, length L will be changing when the block A will be moving. And A is moving downwards. That means length L is associated with the block A. If we take the downward direction as positive, then we will take upward direction as negative. You can take the vice versa as well. You can take the upward direction positive, then downward will be negative. Any one condition we have to follow. Okay. So here I am taking the downward direction positive. That means the upward direction I will have to take the negative. Length L1 is changing when the block E is moving and that is moving downwards. That means dl1 by dt will be UA and that is positive. Why? Because downward direction I have considered as positive. Length L2 will be changing when block A is moving and that is moving downward UA. L3 will be changing when block B is moving, that is moving upward with VB. Why minus VB? Because it is moving in the upward direction. In upward direction, I have taken as negative. C1, C2. C1, C2 have curved length that is around the pulley. That means they will not be changing. So C1 and C2 will be 0. Why? Because C1, C2 will always be constant. They will not be changing whether the block A is moving or B is moving. So the differentiation of a constant will be 0. Now we will simply solve this. 0 is equals to 2UA minus VB. That means VB is equals to 2UA. This is the relation we had to establish. We have find the relation between both the velocities. So in order to solve the pulley problem of a constraint motion, we are simply following the three simple steps. I believe up to this part it is clear to you. Anyone have any doubt in this? We will do a quick recall of the session as well in the last, but as of now, we will move to the next question. Okay, before summarizing our session, ending our session, we will do a quick recall as well. Okay. Question number 2 says, likewise, a constraint is given to us here. Pulley number 1, pulley number 2, and pulley number 3. Three blocks or wages we can say A, B, and C are hanging here. Lengths are L1, L2, L3, L4. Curved length C1, C2, C3 is given. Block A is moving upwards with 1 meter per second. Block B is moving downwards with 2 meter per second. And block C is moving upward with VC. So it is very much clear from the question that we need to calculate the VC. What will be the VC? Okay. We know the three steps are step number one is the total length of the string will be constant. The total length of string will be constant. L is L1 plus L2 plus L3 plus L4 plus C1 plus C2 plus C3. What are the C1, C2, C3? These are the curved part of the length which are around the pulley. In the step number 2, we will differentiate the entire equation with respect to time. So that will be dl by dt is equals to dl1 by dt plus dl2 by dt plus dl3 by dt plus dl4 by dt plus dc1 by dt plus dc2 by dt plus dc3 by dt. Step number 2 is clear. In the step number 3, we will use the velocity separation method. Total length of a string is constant and the differentiation of a constant is 0. That means dl by dt will be 0. So dl by dt is 0 is equals to dl1 by dt. L1 length is connected with block A and block A is moving upward. In the previous question also, we considered the downward direction is positive and upward direction is negative. I'm telling you again, you can take the vice versa also. You can take the downward direction negative, upward positive. The result will be same. Okay. So I am here in this question also. I'm considering that if block is moving downwards, the velocity positive. If block is moving upward, the velocity negative. Block A is moving upward. That means dl1 by dt will be minus. Length L2 will be changing when the block B will move, that is downward with 2 meter per second. Length L3 will be changing when block B is moving, that is downward with 2 meter per second. And length L4 will be changing when block C is moving with BC. I have considered moving upward. That means it is minus BC. Okay. We will simply solve this equation now. 2 plus 2, 4. 4 minus 1, 3. That means 0 is equals to 3 minus VC. So from here, I can conclude that VC is equals to 3 meter per second. It will be 3 meter per second. Unit is always meter. Okay, so these two numerical I have solved based on the constraint motion pulley problems. We will do a quick recall of this. First, I'll give you 2 minutes to have a look at the question. Okay, let's do a quick recall. From the very So we started our session with the very basic, the physics. Entire physics we divide into. Part number 1 is kinematics. Kinematic is part of physics in which we are not following the Newton's law of motion. That means we are solving our problems, we are solving our numerical questions without using the Newton's law of motion. For example, the problems based on center of mass, the problems based on circular motion, the problems based on projectile, and the problems based on the constraint motion. We are not using the Newton's law of motion when we solve these problems. This is the reason we put them in the category of kinematics. The second section or the second part of the physics is dynamics. In this dynamics, we are following the Newton's law of motion. Three laws of motion we already know. There are only three laws of motion. Number one is inertia. Number two is the relation between the force and momentum. What this law says, the law says that force is proportional to rate of change of momentum. The rate of change of momentum is proportional to force. This is the reason we say this law as a force momentum relation law. And the third law is the action reaction law. So if we have some numerical problem based on the action reaction, or we need to find the momentum, we need to find the force, we need to find the inertia, that means we will have to follow the Newton's law of motion, and that is the reason we put them in the category of dynamics. Today, we will be learning about the constraint motion, and in the constraint motion, we already have learned it that we are not using the Newton's law of motion that comes in the kinematic section of physics. Today we will be solving few problems based on the pulley. So the first question we have taken here, that two pulley system is given to us, which A is moving downwards with velocity UA and which B is moving upward with velocity VB. The length of the strings is given to us L1, L2, L3, and the curved length of a string, which is around the pulley axis C1 and C2. We need to find the relation between UA and V. So in order to solve such type of questions, we simply follow three simple steps. Step number one is the total length of the entire string will be constant. Step number two, we will divide this length with time, that will give us velocity. And as we have the velocity, in the step number three, we will use the velocity separation method to solve the equation number two. The equation we will get using this step. Okay, let's solve this particular question. In the step number one, the total length will be L1 plus L2 plus L3 plus C1 plus C2. In the step number two, we will differentiate the entire equation with time. And in the step number three, we will use the velocity separation method. Now, total length of a system is constant. The total length of a string is constant. That means dl by dt will be 0. Now, L1, L2, L3, L1 is the length L1 will change when the block A will move. The downward direction of velocity we have considered positive, and upward direction we have considered negative. You can take the vice versa as well. You can take the negative, downward negative, upward positive, result will be same. Okay. So length L will be changing, length L1 will be changing when block A is moving with velocity UA downward. Downward we have taken positive. That means TL1 by dt will be plus UA. L2 will be changing again when A is moving. That is also UA. L3 will be changing when block B is moving and B is moving upward. So we have taken as minus VB. Curved length will not change because curved length is around the, so that will be same. And the differentiation of a constant is 0. So dc1 by dt and dc2 by dt will be 0. We have find the equation here. We will simply solve this equation and find the relation between the UA and VB. This is our question number one. We have taken one more problem based on the same concept. In this question, Three pulley system is given to us. Block A is moving upward with 1 meter per second. Block B is moving downward with 2 meter per second. And block C is moving upward with VC. We need to calculate the VC. We need to find the value of VC. So in the step number 1, the total length is constant L1 plus L2 plus L3 plus L4 plus C1 plus C2 plus C3. That is constant. In the step number 2, we will differentiate the entire equation dl1 by dt1, dl2 by dt, dl3 by dt, dl4 by dt, dc1 by dt, dc2 by dt, dc3 by dt. And in the step number 3, we will use the velocity separation method. Total length of a string is constant and the differentiation of a constant will be 0. Length L1 is moving when block A is moving upward direction. I have taken negative. So -1. Length L2 is moving with block B moving downwards +2. Length L3 is moving with block B moving downwards again +2. Length L4 is moving when block C is moving upward -VC. So I have a simple equation here. We will solve this equation. 2 plus 2, 4. 4 minus 1, 3. 3 minus Vc is equals to 0. That means Vc is equals to 3 meter per second. So this is our session for today. I believe you all enjoyed this session. And we have learned a very important concept here that the pulley problems may look very difficult, but that are not as such. We will have to follow three simple steps to solve the constraint motion pulley problems, and in these simple steps, we can find the solution. Okay. This is our session for today. Thank you so much. I believe you all enjoyed this session. Have a nice day.